Okay, so today I'm going to do a short example of object-oriented programming that is more graphical than it's text-based. So kind of see the benefits of using object-oriented programming. So in this case, we are going to use a Python module called Py5. You can see it here. It says Py5. And Py5 is a creative coding module that is it's very easy to create graphic application in this. It inherits its functionality from a tool called processing, which is also a creative development environment. So, but this is using Python, and the processing is using a Java-based tool. And I'm just using this to kind of get the environment to do graphics. So the first thing we will need in this to be able to draw, we need to kind of define a base class that handles what colors the object should have in different ways. So I decided to create a base class for all my objects that my other shapes that I want to implement. And base classes, they should be kind of define attributes that all the derived classes will have. So for example, line color, it could be fill colors and stuff like that. That goes into the base class. And also how you want to use the class. So in this case here, I've defined a method here called draw, which is the method you want to kind of, I want to be able to call on a shape to be able to draw itself on the screen. And for the base class here, we are actually not going to draw anything. You can see I have a second method here called onDraw that is called by the main draw function. And the only thing I'm going to do in this class here is to set up the color of the lines, which is the stroke here. I use these attributes here to set that up with the sketch library, and then the fill and the stroke weight. And then that will be the same for all classes, so I will not have to do that in the other classes. And then I have defined an onDraw method that is the other classes will override to implement the drawing functionality. So you can see I put pause here. I will not implement anything here. But in Python, you can't have an empty method. You need always to put something in the indented block. And if you don't want to implement the method, you can just put the pause statement. The only statement in Python that does nothing, but it fulfills a kind of a way of making sure that you can have an empty method. Next, we need to. Yeah.
Why wouldn't I just want to write return 0 and then maybe override the entire function later, or method later?
So why I do this first?
In the onDraw, I could just write a return 0 or whatever. Right?
Yeah, you can have a return 0, but if you don't want to return anything, just have an empty function that does nothing. It doesn't even return anything. You can use the pause method. Mm. So it's a way of just placeholder. Because return actually does something. Yeah. But you could also.
So I would like to have sort of a return or whatever. This is how I think when I code stuff. I return 0 or whatever. And then if I want to override this method in other subclasses or whatever, then I'll do it there.
Yeah. But suppose you have a method that is not by default going to return anything. Mm-hmm. Then if you have return here, this function will actually do something. So that's why pause is useful if you want to kind of just implement something that is a placeholder for an empty function. So, but I agree, you could have a return there as well. But return is a statement that actually does something. Pause is just an empty, no operation. So the particle here, so you can see here I have defined 3 classes here. I have a particle here, which will be a dot, a small point, which will be drawn. I also have a round particle that is a circle shape that I will draw. And you can see here, I defined the classes, but I left them empty here. So these just define that there is a class, but there is no implementation of it. And it's still valid code, so I can run this code here. It will bring up a window. So there is nothing wrong with the code. You can have empty class declarations. So for our particle here, we need to create a constructor.
So if we didn't have that one, but trying to create a particle, the compiler would complain, I guess.
No, you can actually create an empty.
Okay.
Yeah, then it derives from the default object in Python. So, but it doesn't have any meaning more than it's a Python object itself without any implementation.
Well, it would exist, but it take memory space. I guess.
Yeah. So I need a particle, and it needs to be able to put the position here. So I have X and Y. The particle should also be able to move. So I have speed in X direction and speed in Y direction. I initialize my attributes here to be 0. And also I have you can give the X and Y as an input to when you create the class. And I call super init, which we learned was to call over the class above, so the drawable base constructor. So this will call this one here and initialize the colors, default colors of our shape. Then we need to also override, have a draw function. We can the other direction. We need to be able to update the position of the code or the particle. And then you can see here I just add the speed and calculate the new position. And then I need to override the draw method here. So in this case, I just do a simple point. So point will draw a pixel or with the stroke width here in size. So we can try this out here in the main routine here. It's called particle sketch. And particle sketch is the main program that we are going to run. It has 3 methods. Settings, that sets the window size. Setup is called once. And here you can set up your initial variables. And then it will call draw continuously. So here we can do, for example, self.p equals particle like this. And then we can draw this particle here, self.p.draw. Now it could be difficult to see here because I'm not sure how well the point will be visible. Now, there is a small point here. It's black. What we could do is we could, in our particle here, we could do, let's see what it draws with. So now it draws a red dot here. So now we have a basic class that can draw itself on the screen. It can also move itself, but I will come back to that later. Then we will implement another particle. And here we add another attribute here, radius. We initialize our, in a base class here, in this case it's particle, which is derived from drawable base. So we inherit all this functionality here from our particle. And then we add our own attribute here, r. We need to do, in this case, we only need to override onDraw, because onDraw, we already have an update method for moving our shape here, so that we don't need to override. So we only have to implement our drawing function. So onDraw, and you can see the AI has learned how I coded the example before, so I don't have to code it. But then you see ellipse x, y, and then the size of the ellipse here. I will also change it here to be a bit larger here as a default, so we can see it. And now we can add a particle here, self.ellipse equals to round particle. like this. And now we have to have a self dot e dot draw. Now we have to move the circle to see the other one as well, but we will move it to 400. Perhaps we can see both of them. But it doesn't look so nice to have to be able to draw each particle every time. So we should automate this. So instead, we should have a self dot particles here, which is an empty list. And then we just do self dot. We do. Now I'm just going to use. Okay, we can do first. We do this. We just add these two to. Like this. So now we append these to our particle list, and instead of drawing each particle for itself, we do for p in self particles, and then we update and we draw. And this Pi5 or the drawing routine draws every 60 seconds, so it's 60 frames per second we'll draw. So we give the update here a 60th of a second, and then we call draw again. And now we don't have any speed set for this here, so we need to, when we create the particle here, we can do the round particle e dot bx equals to 10. That's 30, like that. And then we should see the circle moving towards the right side, like that. And this uses the polymorphism we talked about here, that we can have particles of different types. We can call draw on each of them because they have their own implementation of the drawing routine. They all share the update routine for having a position that can be moved, and they all and Python calls the appropriate methods depending on the circles we have here. So next step, I will try to do a little more, create more random particles here. So let's say we have 100 particles here. And then we do some randomness here. So we assign them from 0 to 600, different radiuses. We assign different speeds, and we randomize the colors as well, and we append them here to the particle section. And we don't have to actually update anything here, because it will be able to draw these things automatically here. But we will have a problem when we run this here, as you will see. They will at some point kind of disappear, because there is no bounce checking here, or bouncing. So we should add that as well. And we will implement that in the... We also use a class for that, so we will have a box boundary here. So we set it up with our boundaries here, x min, x max, and so on. And we need a method to check if it's to check the bouncing or to check the bounce. So we do def check. Let's see. Yes. So this just checks if we are going to the left side, it will reverse the speed. If we go to the right side, it will reverse the speed. So it will check each particle if they are bouncing here. So what we do here in the setup section, we also need to create a self.boundary like this. And then we will call that in our section here. Update like this. And now you can see that the circles just stay inside here. So this is a very good example of how you can use object-oriented programming to have multiple classes that derive from a single base class that has the kind of base functionality, and then you extend your classes with that, and you don't have to write so much code. So in this case here, the round particle here was really easy to implement. You just only had to implement onDraw method kind of to display itself. The self x, y, self y are already kind of defined from the base classes. And it's also easy, we can add more particles here. We could do a square particle, for example. And now you can see it's smart enough to add width and height. And it also had rect here. So we could do like this. Yeah, we have a problem here with we need a bit I was kind of doing it live here, and the problem is that the check here uses the R, so we could just remove that or we implement a simple R for that as well, but they will bounce as circles here. That's the thing. Let's see if we do. That will solve the problem quickly here.
Perfect.
No. But now you kind of easily could add a different shape here that was a square, and you still have the simple way of looping over your particles here. You just loop over them, and you know that you can call update, you can call draw, and you can check the boundaries here. So that was my thing I wanted to show you today. So I'm not going to lecture too much more today.